Okay, Assalamu alaikum wa rahmatullahi wa barakatuh. Welcome in the online class for today, inshallah. I'm going to discuss with you the principles of qualitative analysis. And inshallah, right now I'm going to share with you the file I'm going to start with. I would like you to focus with me. Inshallah, next meeting, I'm going to make practical test or practical exam and what we are going to do today. So you have to focus, you have to concentrate. It's very, very important. Great. Now I'm going to share with you the file. Okay, can you see this file? Okay. If you'd like to ask me or interrupt me, just talk to me. I cannot see the messages. Okay, let us start. Today, inshallah, lesson is experimental number four. And it will be introduction to the qualitative analysis for anions and cations. I have already discussed with you previously, we have two types of analysis, the qualitative analysis and quantitative analysis. Qualitative analysis, just to know the type of the salt you have, the constituents of the salt, just to know it without knowing its concentration, without knowing its amount. While the quantitative one, you have to determine how many moles, how many grams, the concentration, and so on. Just gentle reminder, if you let an acid to react with a base, they are produces salt and water. And today we are going to identify the salts which came from acid and basis reaction, and any salt contains two parts, anion and cations. The anion came from the acid and the cation came from the base. Okay, the objective for today to become familiar with the chemistry of various cations and anions and to understand the principles of the qualitative analysis. Let us define the qualitative analysis again. Identifying the qualitative analysis is just identification of the constituents contained in a sample of unknown composition. Inorganic qualitative analysis majorly involves the identification of the constituents, elements, or groups present in a simple salt. You will provide it with inorganic salts, and using a systematic approach, a procedure, you have to follow it in order to end up with knowing the salt you have or the constituents of the salt you have. I mean the cations and anions. We classify previously the acids into strong and weak and medium acids. So you can imagine that, or can expect that the salts came from strong acids and weak acids and medium acids. So in order to identify if you have a mixture, say to say, of anions, or if you have okay, in order to identify, you have to follow a certain scheme. Inshallah, I'm going to explain this scheme later on in the next meeting, I mean. But today I'm going to explain the groups according to the classifying of acids. So we're going to classify anions into three groups. The group, the group in which their anions came from weak acids, and this group, it's the first group. It's called diol HCl group, and it contains carbonate, bicarbonate, nitrite, thiosulphate. The group reagent of this one, it's a diol HCl. Okay, the second group came from more stronger acid or a stronger acid than the previous group, and this group it is called sulfuric acid group, and it contains chloride, iodide, fluoride, nitrate, but just we're going to discuss two of them, just chloride and iodide. This group, its name, Conc sulfuric acid group, and the group reagent, it's Conc sulfuric acid. The third group, it's called the miscellaneous group, okay? And just it contains, I would say, three anions: sulfate, phosphate, and borate. But we're going to discuss just only these two, sulfate and phosphate. In this lab, you will learn how to test for their presence and the absence of the anions. How do we identify the cations and anions? The anions, which came from acids, which carry negative charges, anions and the cations react with various reagents. How do you identify them? Just let them to react with a certain reagent, chemical reagent, and kind of reaction happen. And you can identify the reaction with showing the observation. Most of their reactions are accompanied by characteristic visible observations. We use this visible observation to identify the cations and anions. There are many kinds of observations. Some of them color change. Might be you see some color change from reactant to product, or gas formation, evolution of gases, and might be formation of precipitate. You see precipitate is formed. Okay. In this section, we're going to discuss just anions. As we are dealing, we are going to discuss only 8 anions. I have showed you carbonate, bicarbonate, nitrite, thiosulphate, and from the second group, chloride, iodide, from the third group, sulfate and phosphate. And we are not going to deal with a mixture of anions. Our method of analysis is very simple and straightforward. So we will then confirm each anion with specific reactions by performing specific tests for the anion you have, in order to be sure that anion you what expected before. We have classified the anions into 3 groups. Like HCl group, this is the group reagent of the first one. It contains carbonate, bicarbonate, nitrite, and thiosulphate, S2O3 minus 2. The second group, it's a Conc sulfuric acid group. This is the group reagent, and just we're going to discuss just only 2, chloride and iodide. The third group is miscellaneous group. It has no group reagent. There is no group reagent for that group, and just we're going to discuss 2 anions, sulfate and phosphate. Good. Now let us start with the first group, which contains carbonate, bicarbonate, nitrite, thiosulphate. Okay, the first test in the first group and in the second group, it's called the primary test. What does it mean? It means, okay, the reaction of that anion in these 2 groups with its group reagent. And actually, you have to do this test on the salt, not in a solution. So the primary test in the first group involves the reaction of salt with diol HCl. You will see some observations. Let us see what you will see. For carbonate and bicarbonate, actually you will see the same observation. Effervescence and the colorless gas evolves. This gas is carbon dioxide. And you will see this observation for both carbonate and bicarbonate. Okay? The other tests, we call them confirmation tests or confirmatory tests, and you have to do them on a solution. What does solution mean? Solution, it means mixing of the salt with certain solvent and you end up with a clear solution. Okay, so solution, it means you have the salt and just add a few milliliters of water and then add the first reagent, which is mercury chloride. You will see for carbonate reddish brown precipitate of mercury carbonate, and you will see this kind of observation at once on cold without any heating. For bicarbonate, you will see this observation but after heating, reddish brown precipitate, not in cold, you have to heat in a water bath. Okay. The second confirmation test, solution plus magnesium sulfate, you will see white precipitate of magnesium carbonate on cold, and in case of bicarbonate, white precipitate of magnesium carbonate but after heating. Can anybody knows why carbonate gave on cold or gives the precipitate on cold, while bicarbonate you have to heat? Just it's very simple, okay? Because most of carbonate salts are insoluble in water, except just only three carbonate salts: sodium carbonate, potassium carbonate, ammonium carbonates. These are only carbonates which are soluble in water, while the other carbonates, it's insoluble. So that's why it gives the observation on cold. While bicarbonate, all bicarbonate salts are soluble in water. So wherever you have bicarbonate, okay, it's soluble in water. On heating, you convert this bicarbonate into carbonate, which is insoluble in water. Very good. Okay, let us keep going with the first group, which is diol HCl group. The other two anions are nitrite and thiosulphate. The primary test, just the salt plus diol HCl, the group reagent. You will see effervescence in case of nitrite, effervescence and brown fumes on the top of the test tube, and the solution, it changes into pale blue color. Why you see this kind of brown fumes on the top? Once you add nitrite, once you add diol HCl on nitrite salt, NO, nitrogen monoxide, will be produced. Okay, and then once it reaches to the top of the test tube, it reacts with the oxygen in the air, and you end up with nitrogen dioxide. So the red fumes or brown fumes is for NO2, nitrogen dioxide. Okay, very good. In case of thiosulfate, the salt plus the group reagent, you see a colorless gas evolves with suffocating odors, which changes the paper moistened with acidified dichromate from yellow to green. So you will see, by the way, the reaction of thiosulfate, it's very, very weak. Might be you cannot see the effervescence. You cannot see the effervescence, but you will smell suffocating odor gas. And if you let a paper moisten with acidified potassium dichromate, this gas, it changes it from yellow to green. Okay, the other tests are called the confirmation tests. You have to do them in a solution plus silver nitrate. You have white precipitate of silver nitrite in case of nitrite, but in case of thiosulfate, you will see white precipitate, which it changes into yellow and then orange, then brown, and you end up with black precipitate, which is silver sulfide, Eg2S. Okay, that in case of thiosulfate. The other test which we call it redox reaction, which involve reduction oxidation reaction. So you just prepare a solution and add acidified potassium permanganate. Anybody of you know the color of permanganate? It's purple color. Okay, it's a violet color. Once you add acidified potassium permanganate to a solution of nitrite or thiosulphate, you will see the discharging of the color of permanganate. So the color of permanganate discharges, which means that the nitrite is reducing agent, which means nitrite salt reduces the permanganate. In case of thiosulphate, the color also of permanganate discharges, okay, which means that thiosulphate salt is reducing agent. Very good. This is the first group, which is called dial HCl group. Let us keep going and go to the second group, which we call it Conc sulfuric acid group. And just we are going to discuss two anions, just chloride and iodide. The first test we call it primary test, and you have to do it on the salt plus the group reagent. The group reagent is Conc sulfuric acid. Okay, you will see in case of chloride effervescence and colorless gas evolves. This gas, it's HCl. How you can identify the HCl gas? Just this gas causes white fumes or produces white fumes with a paper moistened with ammonium hydroxide. Okay, I'm going to, by the way, I'm going to show the videos for all these tests. Okay, in case of iodide, you will see very strong reaction, effervescence and dark violet condensed fumes. And this kind of fumes are a mixture of two gases, iodine gas and the hydrogen iodide gas. Okay, the other tests we call them confirmation tests, and you have to prepare a solution. How do you prepare a solution? Just salt plus water and just them or mix them very well, and then add silver nitrate. You will see white precipitate of silver chloride, and this precipitate is soluble in ammonia or ammonium hydroxide. By the way, this one, ammonia, it's the same as ammonium hydroxide. Okay? Okay, in case of iodide, you will see yellowish white precipitate of silver iodide. The other confirmation test or confirmatory test, solution plus lead acetate. So you will see white precipitate of lead chloride in case of the chloride anion, and this lead chloride precipitate is soluble in hot water. If you add this test tube with that precipitate in a hot water bath, okay, you will see this precipitate is disappeared. It's become soluble. Once you let it to cool again, you will see the precipitate bipolar. Good. In case of iodide, the solution plus lead acetate, you will see yellow precipitate of lead iodide. Okay, this is the second group. Let us go to the third group, which is miscellaneous group, and we are going to discuss just only two anions, sulfate and phosphate. Great. By the way, this group has no group reagent, so there is no primary test. So all tests are confirmation tests, and you have to do all tests in solution. Nothing you have to do in the salt. So all solutions, all tests you have to do in solution for the third group. The first confirmation test is solution plus silver nitrate. You will see white turbidity precipitate. You will see the reaction become turbid, which means you have a precipitate of silver sulfate, Ag2SO4. And this precipitate is insoluble in nitric acid. We are going to add nitric acid using dropper, and you will see this turbidity still without disappearing. In case of phosphate solution plus silver nitrate, you will see Canarian yellow precipitate or canary yellow precipitate of silver phosphate, Ag3PO4. The second confirmation test, just solution plus barium chloride. Okay, in case of sulfate, you will see white precipitate of barium sulfate, and this one also insoluble in dial nitric acid. Insoluble in dial nitric acid. Do you know why the precipitate of sulfate the salts of sulfate don't dissolve in nitric acid? Very simply because sulfate came from sulfuric acid, which is more stronger than nitric acid, so nitric acid cannot replace SO4. So they are not dissolved in dial nitric acid. Okay, in case of phosphate, solution plus barium chloride, you will see white precipitate of barium phosphate, and this is the chemical formula of barium phosphate. Maybe I can ask what the formula of barium phosphate says. To say it's Ba3BO4 by 2, and why 2 here? Because the charge on the barium is plus 2, and why 3 here? Because the charge on PO4 group is minus 3. And this precipitate is soluble in dial nitric acid. If you add nitric acid on that one, okay, you will see that the precipitate is disappeared. Okay, the solution plus lead acetate, in case of sulfate and phosphate, you will see white precipitate. In case of sulfate, white precipitate of lead sulfate, and in case of phosphate, you will see white precipitate of lead phosphate. For example, maybe I can ask you in the quizzes on or in anything, in any time, how you can differentiate between phosphate and sulfate. So you have to choose a certain reagent which gives you different observation. So, for example, this one you cannot use it to differentiate between sulfate and phosphate. But for example, you can differentiate between them using this test. Using this test, the reaction of solution with silver nitrate. Here you have white turbidity precipitate or white precipitate, but in case of phosphate, you will see yellow precipitate. The most important test you can differentiate phosphate from sulfate is the solution plus magnesium mixture. Magnesium mixture is a reagent which formed by mixing 3 components, magnesium sulfate plus ammonium chloride plus ammonium hydroxide. In case of sulfate, nothing happened. There is no reaction. But in case of phosphate, you will see white precipitate of magnesium ammonium phosphate. Magnesium ammonium phosphate. So you can differentiate between phosphate and sulfate using that one. And by the way, magnesium mixture is a characteristic test, or a specific reagent for phosphate. Okay, now I have already discussed all the 3 groups. You will see, okay, in the lab you have to use that items, test tubes, test tube holder, test tube rack, and water bath. The chemicals, you should use the 8 anions sulfate. I'm sorry, this should be nitrite. Here it should be 2. Okay, nitrite, thiosulphate, carbonate, bicarbonate, and chloride, iodide, and also phosphate. You will see the reagent you are going to use to identify these anions. For example, using dial HCl, Conc sulfuric acid, mercury chloride, magnesium sulfide, acidified permanganate, and the lead acetate, barium chloride, and the magnesium mixture. All solutions are provided in a dropper bottle. You are going to use this dropper. The procedure, I'm going to show you the videos and how you do this kind of tests, and I'm going to discuss with you during the video. And let us go to the videos right now. I'm going to share the video with you. بسم الله الرحمن الرحيم. First, we are going to discuss the first group, which is diol HCl group, and we will discuss for anions, carbonate and bicarbonate, nitrite, and thiosulphate. Now I'm going to share the first video. Okay, here it is. Here we are. Okay, we start with carbonate and bicarbonate. Okay, this is carbonate and bicarbonate. We are going to do the primary test, which involves the reaction of the salt. Just add few crystals in dry and clean test tube, and then just add diol HCl. This is a primary test for the first group, diol HCl group. Okay, diol HCl, just set on this salt. What this observation, just effervescence, you can see it and you can hear the effervescence, and the colorless gas evolves. This gas is carbon dioxide. The primary test for bicarbonate will be the same, just in dry and clean test tube, just add few crystals and then add the group reagent, which is diol HCl. You will see the same observation for carbonate and bicarbonate. Can you see the effervescence? And this gas, which is evolving, is carbon dioxide. Now we are going to do the confirmation tests. You have to prepare a solution. Okay, how can we prepare a solution? Let's see. In a dry test tube, just take few crystals of the salt you have, and in that case it's carbonate, and then add few milliliters of distilled water. Okay, just distilled water or deionized water. Okay, add few milliliters, 2 milliliters, and then shake them well or mix them well in order to have a clear solution. See, you can see the clear solution, which means the salt is dissolved in the water. And then add, okay, the first confirmatory test reagent, which is mercury chloride. In case of carbonate, you will see reddish brown precipitate at once and cold. See, reddish brown precipitate and cold at once. But in case of bicarbonate, you will see this precipitate after heating. Okay, first you have to prepare a solution of bicarbonate, just a few crystals in a dry and clean test tube, and then add few milliliters of water. Okay, in order to prepare the solution. Okay, just add milliliters of water, and then mix them well, or shake the test tube very, very well, and then add the mercury chloride. This mercury chloride chemical reagent, you will see nothing. The solution is still clear. Why? Actually, mercury bicarbonate is formed, but it is soluble in water. If you let this reaction mixture to be heated up, you will see reddish brown precipitate is formed. Actually, it is started to form. You can see that. Okay, by heating. You can see the reddish brown precipitate. Great. Very good. Let us go to the second confirmation test. That's just reaction of carbonate and bicarbonate with magnesium sulfate. First, you have to prepare a solution, and you know how to prepare a solution. Just few crystals plus water. Just mix them very well, and then add the reaction to that solution. Okay, just add the reagent. You will see white precipitate is formed. Should be at once. Okay, on call. Sorry for that. You can see the turbidity, which means the precipitate is formed of MgCO3, magnesium carbonate. You can see the turbidity. Very good. The same observation you will see for bicarbonate, but after heating. First of all, you have to prepare a solution, few crystals, plus a few milliliters of water. And then mix them very well. Okay, great. You have a clear solution. And then add just only magnesium sulfate. Nothing will happen. Magnesium sulfate MgSO4. You will see nothing on cold. Okay, nothing happened. So you have to heat in a water bath in order to see this kind of turbidity. Now we are going to heat in a water bath. Okay, just hold the test tube and transfer it from the test tube holder to the water bath. Okay, water bath. Just we have to mix very well, and the water should be boiling. Should be boiling, and now you can see the turbidity is formed after some time, which means the bicarbonate is converted to carbonate. Now we are going to the second part of the second video of the first group. Okay, nitrite and thiosulphate. Sorry, just talk to me. I cannot see what you are writing. Okay, let's see. This is the second part of the first group. Forget about this number 2, still group 2, group 1, then HCl group. Now we're going to the primary test. So primary test, you have to do them on the salt, solid salt. This is nitrite, NO2 minus 1. Just a few crystals plus a few milliliters of water. And no, I'm sorry, this is the salt. Just a few crystals. This is primary test. Okay, then add the group reagent, which is diol HCl group. Okay, you will see effervescence and NO is evolves, but the reaction is not strong as with carbonate, but you can see the effervescence. Okay, and once this gas NO reaches the top of the tube, it should be converted to brown fumes. You can see the fumes in the whole tube. I'm going to show it right now. You can see the effervescence. Can you see the brown fumes? Okay, it starts to appear. And why it doesn't appear at once? Because NO reduce the first and then reacts with oxygen. For thiosulfate, the reaction is not so strong like previously, okay? But suffocating odor gas is evolved, which is SO2, okay? And you will see the solution becomes pale yellow. After shaking, you will see this solution becomes pale yellow or turbid.
We have a very bad suffocating odor.
Okay, which is SO. Now we are going to confirmation tests. Okay, for nitrite, just you have to prepare a solution first. Just a few crystals plus few milliliters of water, just mix them very well in order to have a clear solution. Just mix them or shake the test tube strongly, so to say, without any pouring, okay, of the solution. Then add silver nitrate reagent. You will see white precipitate. White precipitate is formed of silver nitrite, AgNO2. Okay. In case of thiosulfate, okay, we are going to do it in a solution because it's a confirmation test. Just prepare a solution first, few crystals plus milliliters of water, and then add, let's see. Silver nitrate, you will white precipitate, which converted to yellow, to gray, to brown, and then you end up with black precipitate. First white, change it to yellow, and you end up with black one. Just I'm going to check the test tube, and you will see the black precipitate, which is silver sulfide. Very good. Silver sulfide, Ag2S. Okay, the second confirmation test, which is redox reaction, we're going to see the ability of reduction of that anions to the oxidizing agents, which is, we're going to see here acidified permanganate. First, you have to prepare a solution. Few crystals plus water. And now we add acidified permanganate, which is of purple color or violet color. Okay, you will see its color on the test tube border or test tube edge, purple, and then it changes to brown. See, it's a violet. Once it reaches the solution, it becomes brown. It discharges to a brown color, which means nitrite is a reducing agent. The same observation you will with thiosulfate, but you have to prepare a solution first. In a dry and clean test tube, add a few crystals plus water, and then mix them very well, and then add the acidified potassium permanganate. You will see the discharging of permanganate, and the color of the permanganate is changed from purple to brown, and this confirms that the thiosulfate is a reducing agent, and this is a redox reaction. It's oxidation reduction reaction. Very good. Now let us go to the second group, which is Conc sulfuric acid group, and just we're going to discuss two anions, which are iodide and chloride. Here we are. Okay, great. And forget about this three. It should be group 2. And the group reagent, it's Conc sulfuric acid. Okay, and first we are going to do the primary test, which you have to do it on the salt. Okay, just free crystals, and then add the group reagent directly to the salt. In a dry and clean test tube, just add Conc sulfuric acid reagent, and we use droppers for the acids. Okay, it's very dangerous. Okay, you will see very strong reaction, and HCl gas is evolved. You can see the effervescence. See this gas, it's HCl gas, which forms white fumes with ammonium hydroxide. Just use a glass rod which moisten with ammonium hydroxide, and then expose it to the gas, HCl gas. You will see white fumes is formed. You can see that. Great. Very clear. Very good. Very good. In case of iodide, okay, this is the primary test for iodide. You have to do it on the salt, and you have to differentiate between the primary test and the confirmation tests. Primary test, you have to do it in the salt, just in the salt, in the dry and the clean test tube, and just add the group reagent. You will see the observation corresponding, which is corresponding to that analysis. In case of iodide, you will see dark brown condensed fumes, and also very strong reaction. And this kind of red brown condensed fumes are mixture of iodine gas and the hydrogen iodide. You can hear also the effervescence. Now we will go to the confirmation tests. The first confirmatory test, solution plus silver nitrate. You have to prepare a solution first, few crystals plus few milliliters of water. Then mix them very well. Then add the chemical reagent, which is silver nitrate. You will see white precipitate is formed. Which is soluble in ammonium hydroxide, AgCl. Once you add ammonia or ammonium hydroxide, okay, a few drops, you will see this precipitate is disappeared. Okay, just add a few drops. You will see the solution become clear. Just mix them very well with the ammonium hydroxide. You end up with very clear solutions, which means that the precipitate is dissolved in ammonium hydroxide. In case of iodide, okay, just a few crystals and add some water milliliters in order to prepare a solution, and then add silver nitrate. Just mix them first, then add silver nitrate. You will see yellowish precipitate or yellow precipitate. See, it's yellow precipitate. The second confirmatory test is solution plus lead acetate. Solution plus lead acetate. You have to prepare a solution first, few crystals plus a few milliliters of water, and then add lead acetate. In case of chloride, you will see white precipitate from lead chloride. Can you see that white precipitate? It's a very clean. And this precipitate is soluble in hot water. So we're going to put it in water bath, and you will see later on this white turbidity is disappearing. And then we are going to add, after dissolving in cold water, in order to precipitate it again. So the solution becomes clear. Can you see that? Okay, just wait some time. and put it in the water, bath. Can you see it become very, very clear with heating and with time? Yeah, which means the lead chloride is dissolved in on heating. If you let this solution or this test tube, or if you put it in cold water, you will see the precipitate is formed again. Just we're going to mix them again, okay, and you will start the crystals. You can see the crystals start to re-precipitate it again. The turbidity starts to, starts to appear. You can see that. Great. So lead chloride is precipitated on cold. Okay. Okay, let us do the same test for iodide. Just you have to prepare a solution first. I would like you to be with you. Don't leave the laptop and go away. Do not go away. Okay, just prepare a solution, mix the salt with water, and then add lead acetate. In case of iodide, you will see yellow precipitate, Canarian yellow precipitate. Very, very clear. Okay, which is lead iodide. PbI2. Now we are going to see the third group, which is miscellaneous group, and just we are going to discuss two anions, just sulfate and phosphate, and this group has no group reagent, and all tests you have to prepare a solution, nothing you have to do in this salt, solid salt I mean. Okay, here we are. Okay, forget about this number. It should be 3 miscellaneous group without no group reagent. Just we're going to discuss two anions, or to test two anions, sulfate and phosphate, and all tests are done in a solution. So you have to prepare a solution first, few crystals and a few milliliters of water, and just mix them very well. Then add silver nitrate. In case of sulfate, you will see white precipitate. Just mix them very well. You will see the turbidity. Just mix them very well. Okay, this turbidity, which is silver sulfate. And by the way, okay, let's see. The second one is phosphate. You have to prepare a solution of phosphate, a few crystals of the salt, plus milliliters of water. Just mix them very well, and then add silver nitrate. Silver nitrate reagent. You will see yellow precipitate. You can see the yellow precipitate. It's very, very clear. Very good. Great. And then go to the second confirmation test, which we are going to do using the barium chloride chemical reagent. Okay, just prepare a solution of sulfate first by mixing the salt with water. Great. Then add water. Then add barium chloride. You will see white precipitate which is insoluble in dial nitric acid. If you add few drops of nitric acid, dial nitric acid, okay, nothing will happen. The turbidity is still the same without disappearing. Okay, you can see that. Okay, just add nitric acid, just mix them, another few drops. The precipitate is still as it is without any dissolving. And why that happens? Because sulfuric acid is more stronger than nitric acid. Okay, in case of phosphate, also prepare a solution and then add barium chloride, you will see white precipitate. But actually this precipitate will dissolve in nitric acid. Let's see that. Let us see that. Okay, solution plus barium chloride, also white precipitate. You have to mix them very well, okay? You have to mix them very well. If you add few drops of nitric acid, you will see this precipitate disappeared. You can see that. It's very, very clear. The solution becomes clear, and when mixing, you will see the disappearing of that precipitate. Great. Very, very good. Now we are going to do the lead acetate conformation test, and you will see the same results for both white precipitate in case of sulfate and also white precipitate in case of phosphate. You have to prepare the solution first by adding the salt to the water and just mix them very well, and then add lead acetate. You will see white precipitate is formed at once, directly. Great. Very, very good. In case of phosphate, PO4 minus 3. Okay, just prepare a solution first by mixing water with the salt. Then add the lead acetate to a solution you have already prepared. You will see white precipitate is formed, so you cannot use that confirmation test to differentiate between both sulfate and phosphate. The most important test for phosphate is magnesium mixture. You can identify the phosphate by that test. Okay, but we are going to do it also for sulfate to see nothing happen. Just prepare a solution, mixing a few crystals with a few milliliters of water, then mix them very well, and then add magnesium mixture. Nothing will happen. No reaction. See, there is no any reaction. No reaction. Just remind you the magnesium mixture is a mixture of 3 components, magnesium sulfate and ammonium chloride and ammonium hydroxide. Now we are going to do this test for phosphate. Just prepare a solution first, a few crystals of phosphate plus a few milliliters of water, and then mix them very well, and then add the magnesium mixture reagent, and you end up with white precipitate is formed at once. And as I have already mentioned to you, this test, it's very, very specific to phosphate anion. See, adding a magnesium mixture, you will see white precipitate is formed at once from magnesium ammonium phosphate. From magnesium ammonium phosphate. With this test, alhamdulillah, thanks God, I have already showed you all videos, all tests for the anions, and we have already discussed 8 anions. Inshallah, next meeting I'm going to do practical test for that anions. Before that, I'm going to explain the scheme. Okay, certain procedure. You have to follow them in order without any changing the orders, and you end up with knowing that anion you have. Okay, inshallah, I'm going to take the attendance right now. Just be with me.